Nanotechnology can be seen as the branch of controlling the world and reality. It's the evolution of a powerful and dangerous technology. However, to understand what it really means, we need to go deeper. More than just an invention, it's already a direct evolution of technology itself. It means having the ability to manipulate matter, as it sounds, at the atomic and molecular levels. When people talk about it, they often refer to nanobots, small objects, or curing diseases with nanobots. And while it's true that they fall under that concept, it's not even a single part of what it is. And if you still don't get it, let me give you a more basic example. What is technology? Well, the simple expression is something not found in nature that makes our lives easier. It is commonly believed that only electrical devices are technological, but that's not true. Chairs, tables, houses, they're all technology. Our whole society is a representation of it. Now, let's talk about what nano means, which is interesting here. Nano is part of the prefixes of the International System of Units. And before you get lost, it's very simple. It's the scale where we go from kilograms to hectometers to meters and down. So where does nano fit in? To make it clear, remember that 1 meter is 100 centimeters, which is 1,000 millimeters. And without even getting to nanometers, do you know how much a meter is in micrometers? 1 million. Microscopes, which are micro, see only that. And do you know how small they are? In just one strand of your hair, there are 100 micrometers. But we're talking about width. So, do you know how many nanometers are? To have 1 meter, you would need 1 billion nanometers. It's an absurd amount. This means that nanotechnology is a creation not of nature, made to make our lives easier, and is measured at the nanoscale, which is like dividing a meter into 1 billion parts. At these dimensions, materials exhibit unique physical and chemical properties compared to their counterparts at large scales. From this scale, you can directly alter matter, and based on what we've said, it's something intended to alter that matter to do unnatural things, like make an aluminum stick into a magnet. But this falls short as its potential lies in many other areas. We shouldn't limit ourselves only to what we said before, but this is where we see its full potential. For example, greater strength. Nanomaterials such as carbon nanotubes tend to have higher tensile strength, making them useful for creating stronger and lighter materials. Better electrical conductivity. Nanomaterials such as graphene have exceptional electrical conductivity, which can improve the performance of electronic devices. Improved thermal properties. Materials at the nanoscale can conduct heat more efficiently or change their properties. For example, if we were to divide gold into nanometers, it would change from requiring 1400 degrees to melt to only 800 degrees. Increased reactivity. This is a bit more complicated, but there's a high correlation between the surface area and volume of nanomaterials, which increases their reactivity, making them useful for catalysis and other chemical processes. It's important to clarify that nanotechnology falls into 2 specific categories that accomplish all of this. Top-down approaches. This means starting with a bulk material and carving away parts to create nanoscale structures. These approaches include something like photolithography, which is the process used to create circuits inside phones and computers, making what's called semiconductors. Bottom-up approaches. These work by building a structure using very small building blocks, such as atoms or molecules that assemble themselves. This is done through a process called chemical vapor deposition, which means that these bricks are deposited on a surface and organize themselves when heated in a gas. One you put together, the other puts itself together. We've got several applications in this area, like nanomaterials. Here we encounter theories and discover objects in which we have graphene. developed by researchers at the University of Manchester. Graphene is a single layer of carbon atoms arranged in a two-dimensional structure. It's incredibly strong, light, and has excellent electrical conductivity, making it a promising material for a wide range of applications. Uses in aerospace research and construction. Its use in the aerospace industry has been proposed to create lightweight yet strong components that improve fuel efficiency and performance. In construction, nanomaterials improve the durability and functionality of building materials, as we've explained. What is also an interesting use for nanotechnology is its remarkable application in the medical field. Imagine a world where doctors can send tiny intelligent particles into your body to fight diseases at the cellular level, precisely target cancer cells without harming healthy tissue, and even repair damaged organs from within. One way to use this technology is targeted drug delivery. This could deliver drugs directly to disease cells, minimizing side effects and improving the effectiveness of treatment. For example, researchers at MIT and Harvard are developing nanoparticles that can specifically target cancer cells, improving the precision of chemotherapy. Or nanorobots for surgery. Those who thought of nanobots when we talked about nanotechnology must be cheering. Okay, this is largely theoretical, but nanorobots have the potential to perform minimally invasive surgery, navigate through the bloodstream, and repair tissue at the cellular level. There is also diagnostic imaging. Translated, this means that nanoparticles can enhance contrast in imaging techniques, such as magnetic resonance imaging, MRI, allowing for an earlier and more accurate diagnosis of disease. This technology is also used for advanced prosthetics and implants. Nanomaterials can improve the integration of prosthetics with human tissue, not to mention blend in with it. Yes, we can upgrade our bodies too. But not only in medicine, but also in other fields like electronics. It could help a lot. In fact, too much. Not only in making nano devices, but in making devices with more powerful and smaller components, among which we find semiconductors. These are under development, and the idea is to make them with carbon nanotubes to make transistors that are significantly smaller and faster than traditional silicon-based ones. Quantum dots. These are semiconductor nanocrystals with unique optical properties that companies like Samsung are using to create quantum dots that improve the color and energy efficiency of displays. Flexible electronics. Finally, devices that look like rubber and are more resilient, as nanomaterials enable the development of flexible and portable electronic devices with applications in consumer electronics, healthcare, and beyond. But where is all this technological momentum coming from? Well, it's a pretty interesting story. The idea of nanotechnology first appeared in a 1959 lecture by physicist Richard Feynman. There's plenty of room at the bottom. He dreamed up the idea of tinkering with individual atoms and molecules. The term nanotechnology itself got a boost in the 80s from K. Eric Drexler, who wrote a lot about molecular nanotechnology. Some of the key breakthroughs that really kicked things off were the invention of the scanning tunneling microscope, STM, in 1981, which allowed scientists to look at individual atoms, and the discovery of fullerness and carbon nanotubes in the 80s and 90s, which demonstrated the unique properties of nanomaterials. Since then, the establishment of research institutes and major advances in nanofabrication techniques have made nanotechnology an important and growing field. One big concern is health risks, because these tiny nanoparticles can easily get into the human body and potentially cause health problems. So we need more research on that. Then there's the environmental impact. The production and disposal of nanomaterials must be handled carefully to avoid environmental disruption. We'll need to set some rules to make sure that nanotechnology is developed and used responsibly, which means solid regulations and ethical guidelines. Right now, we have some cool inventions and advances on the horizon, but we're still in the baby steps. Still, no one is ignoring the potential to disrupt industries and improve lives like never before. By continuing to explore this technology in a responsible way, we can tackle some of today's toughest challenges and pave the way for a more advanced, sustainable future. What do you think? If you like this, give it a thumbs up and subscribe. See you next time.